Okay, good morning, afternoon, evening, or whatever time you happen to be watching this video. This is Mr. Simonian coming at you from the electric interwebs on Friday after school. If you were in my second period class, then I had a little tech issue where somehow I deleted like 4 or 5 slides that I was supposed to show you guys, so super sorry about that. Where we were going to continue from where we left off in class was I was about to have you guys try this example on your own. So what I'd like you guys to do is pause the video and give this question a try. Try to work all the way through the problem until you answer the question and notice that it has 2 parts. What's their total distance and their total displacement? So your answer is going to have 2 parts. Try to get an answer, or at least try to get as far as you can. When you have answered the question, or if you get stuck and don't know how to move forward, only then play the video and check your answer against my solution. So give that one a try, take a couple minutes to see how it goes, then we'll come back and make sure that we're in agreement. Welcome back. Hopefully this question went well for you. Just to, whoops. Sorry about that. Just to make sure that we got the answer, I wanted you to see that, whoops, sorry, y'all. So just to make sure that we're getting the answer right, what you would want to get is that the distance was 44 kilometers and the displacement was 20 kilometers in the positive direction, or you could also say that it was 20 kilometers to the east. So let's think of a couple different ways that we could answer this question. It's one-dimensional motion, so one way that you could answer this is you could draw your coordinates. It says that the student starts at the origin, so that means that they're starting at x. That means that the starting position is at the origin at 0. So if here's my origin, this is where I am starting. So this is my starting point. So this is my start, would also be referred to as the initial position. And that's at this x coordinate, x equals 0. And what happens is that we move 32 meters to the east. So we're told that from the origin, we move 32 meters east. So you have both a magnitude, how far you're moving, and a direction to the east. And remember that whenever you're dealing with cardinal directions, the thing you want to remember is never eat sour watermelon. And that's how you can figure out your north, east, south, and west directions. And then because east is the same thing as pointing to the right on our axis, anything that moves to the east, any vector to the east is going to be have a positive value. And because the west points in the negative x direction, anything that moves to the west, any vector that points to the west, is going to have a negative sign associated with it. So if we move 32 meters east, then east means positive, and 32 meters is how far. So I move 32 meters to the east or to the right, and that means that if I start at 0, I'm going to end up at 32 meters to the right of that position. So that's going to be my second point. That's going to be where I end up when I move 32 meters to the east. That vector, my displacement, is a vector that points from where I started to where I end up. And this is my displacement vector for the first part of my trip. And it was 32 meters to the east. So positive 32 meters. And that was the first thing that I did. And if that was the only thing that happened in the problem, then we'd be pretty good to answer what was the distance and the displacement. But that's not the only part of the problem. What they then say is that, so we move 32 meters east, and then we move 12 meters west. So from this point, we're going to end up going 12 meters west from where we are right here. And if I go 12 meters west, that means to the west would be to the left. And if I go 12 meters to the left, then where I'm going to end up, if I do 32 minus 12, that's going to be my new position. My new position is going to be right here at x equals 20 meters. And this right here is going to be where I end up, right? So this is my end point or my final position. And to go from the 32 to the 20, my displacement was 12 meters west. So remember, west is to the left, which is negative. So I went 12 meters west. And that's this displacement. So that's my second displacement. And that was 12 meters to the west. So negative 12 meters was that second displacement. The question is asking me, what was my total distance and my total displacement? So your displacement is always a vector that points from wherever you started to wherever you ended up. So my total displacement is this vector right here. That's my total displacement. And if you're just looking at the picture, you can find what this is because this vector points to the right, which means it's positive, and it has a magnitude of how much? It has a magnitude of 20 meters. So therefore, my total displacement is positive 20 meters. That overall, what happens is that I ended up 20 meters to the right of where I started from. That's what the plus tells me, that that's positive 20, that I moved to the right 20 meters. And that's the graphical way that you can do this, right? Figure out my first displacement, figure out my second displacement. The total is just, the displacement for the total trip is just a vector that points from where I started to where I ended. And that's how I got this guy right here. And that's one way that you can do it. But the other way to do it is to recognize that a total is just adding up all of the individual things that we're talking about. So in other words, if we think about our individual displacements, and so basically I'm just going to put them in a column here. The first displacement was that positive 32 meters. And the second displacement was negative 12 meters. And if I want to know the total displacement, then I'm just going to be finding what I get when I add up all of the individual displacements. So my total is what I get when I add all of these displacements up, I get the total displacement. Just like if you wanted to find the total age of a class, you would add up all of the individual ages of the people in the class to get the total. It's the same thing with the total of anything. So if I want the total displacement, I'm just going to add these quantities together. And because displacement is a vector, I need to include the plus and the minus whenever I'm combining these numbers together. So I'm going to end up doing 32 minus 12. And if I do 32 minus 12, or 32 plus negative 12, that's going to give me a positive 20 meters. And so notice that no matter if I find the total displacement doing like calculations by adding up the values, or if I draw out my vector, either way I should get the same answer. This total displacement tells me the exact same thing as the vector that I drew on my diagram. And that's my total displacement. That's one part of the question. I moved 20 meters to the right. The plus sign tells me I moved to the right. And the 20 meters tells me how far. So my overall displacement was 20 meters to the right. And that's how you find the total displacement. You just add up the individual displacements. And if you want to find the total distance, what you're going to do is you're just going to add all of the individual distances. So like the first distance is the magnitude of the first displacement. The second distance is the magnitude of the second displacement. If we had more displacements, if we had more displacements, then we would add those on here to find the total distance for those. But since we only have two terms, we're just going to do the magnitude of the first displacement, which was positive 32. And really, I'm not even going to write the positive sign because the absolute value makes whatever's inside it automatically positive. So for the first displacement, I'm just going to have a 32 meters, always positive, plus the second displacement. And remember, I'm taking this negative 12, putting it inside of the absolute value function, which means that it's going to come out as positive. The distance that I traveled here was just 12 meters. I went 32 meters to the right, and then I went 12 meters to the left. But the total distance that I traveled was 32 plus 12. And that's exactly what the total distance tells me. And if I do 32 plus 12, that's how you get the 44. 32 plus 12 is 44. So that's how you would get the total distance. Two different ways to do it, right? You could look at your vectors and look at the magnitudes of each of those, and you would also see it's 32 plus 12, which is 44. And then the math way is to use your absolute value functions to convert these displacements into distances by basically just ignoring the direction. So just making all of these positive whenever you get the distance. The total distance is a scalar, which means that it doesn't have any direction associated with it. So when you're finding the total distance, you never include the plus or the minus, you never include the negative signs. Every distance is always positive. So that's why it ends up being 32 plus 12 for the total distance, which gives me 44. And so if we are comfortable with this and how we're basically just noticing that we can read the statements to find our displacements, right? 32 meters east meant that my first displacement was positive 32 meters. 12 meters west meant that my second displacement was negative 12 meters. That's really helpful for reading a problem and coming up with your answer, just, or at least skipping some of the steps to get your answer just based on the reading of the problem. And so I have another example that can help us illustrate how we can pick out a lot of information in the problem by just being careful about how we read the question. So on this example, we're being told that there's a busy parent that lives along the x-axis. They're starting from their home, so that's where they're beginning at their home. That's the initial point, and their home is at the origin. So they're starting at x equals 0 on our coordinates, and then they're going to make the following series of trips. They're going to go 24 kilometers to the right to get a haircut. Then they're going to go 42 kilometers to the left to pick up their kids. From there, they're going to go 58 kilometers to the right to get some groceries. And then they're going to go 40 kilometers to the left to get back home. And we're concerned with the total distance and the total displacement over the entire trip. So I want to do the displacement first, the total displacement. And the way to do the total displacement is to basically just add up all of the individual displacements, right? The total displacement is going to be adding up all of those individual displacements. So if I have 2, then I would add up 2. If I had 3, I'm going to add up 3. If I have any extras, if I have any more displacements, then I would just add those on as well. The ... means that I could just keep on adding displacements. If my trip had 50 different displacements, then I would add all 50 of those things up like this. And that's what we're going to do right here. We're just going to set up a column for our individual displacements. So we've got the first motion, the second, the third, and the fourth. We did 4 individual steps, and that's what we're going to put here. Our displacements for each of these parts of our trip. So the first thing that we did was we went 24 kilometers to the right. So if we're moving to the right, we want to think of, because displacement is how far you moved and in what direction, we want to think about, did we move to the right or to the left? And is that positive or negative? So if we move to the right, remember to the right is along, if we're moving to the right, that's along the positive x-axis. That's in the positive direction. So if we're moving to the right, then that's a positive 24 kilometers, right? 24 kilometers to the right. So the plus sign means that it's to the right. And then I'm moving 42 kilometers to the left. So just like the opposite, if we're moving to the left, then that means, so to the right is positive, that means to the left is negative. So if I'm moving 42 kilometers to the left, then that means it's a negative 42 kilometers for that second displacement. How far I moved and in what direction. Hopefully from there we could figure out what the third displacement is going to be. If I move 58 kilometers to the right, that's going to be a positive 58 kilometers. And the last thing I do is I move 40 kilometers to the left. So to the left, 40 kilometers. These were all of my individual displacements, right? That's the first, the second, the third, and the fourth. And if I want to get the total displacement, all I'm going to do is I'm just going to add up all of these numbers. And so that's where your calculator is going to be handy, unless you're really good at adding and subtracting numbers in your head. Then what you're going to want to do is, and I'm a big fan of Desmos. I would recommend using Desmos, the scientific calculator for this class. And so we're just going to put in those numbers with their signs, right? So we're doing 24 plus negative 42 plus 58 plus negative 40. And so notice that because we started at our home and we ended up at our home, the total displacement comes out to 0. That basically all of the distances and their directions end up canceling each other out. So when we do 24 minus 42 plus 58 minus 40, we get a total displacement of 0. We got a total displacement of 0. And that is something interesting, right? That means that the displacement can not only be positive and negative, but the displacement can also be 0, depending on the problem. And in this case, because we started at home and we ended at home. So the reason that the total displacement was 0 is because our starting point was the exact same as our ending point. If where you start is where you end up, then you have no change in position, right? That's what displacement is. It's how your position changes, how far you moved from where you started and in what direction. But if you start at the origin and you end at the origin, then your change in position over the total trip is your final position, which was at the origin, minus your initial position, which is also at the origin, and then you end up with a total displacement of 0. And it doesn't matter where you start. If you started at 10 kilometers to the right, and then you ended up at 10 kilometers to the right, your starting position would be 10, your ending position would be 10, you do 10 minus 10, and you'd still get 0. So anytime your starting point is the same as your ending point, that's going to mean that your displacement is equal to 0. So, and that's what we saw here. That's how you would get that total displacement, just adding up the individual displacements, including their direction, because they're vectors. When we add them up, we have to include their direction if they're positive or if they're negative. And that's what makes displacement a little bit harder than just the distance. Because when we're talking about just the distance, that's only how far you go. It doesn't tell you anything about the direction of travel. So we traveled a distance of 24 kilometers at the first time, and then we traveled the distance of 42 kilometers the second time, and then it was 58 kilometers, and then it was 40 kilometers. Remember, the distance is only how far you go, tells you nothing about the direction that you took to get there. So we're just ignoring the direction when we're adding the total distance. And the total distance is found the same way that you would find the total displacement, and that you're just, well, the same way that you would find the total of anything. We're just adding up the individual values. So the total distance is going to be all of these distances added together, right? You could basically think of the total distance as being the first distance plus the second distance plus the third distance plus however many other distances there are, right? So in this case, because there's 4, we would have a 4th one, and then we would stop. So this is the first one, the second one, the third one, and the 4th one, and we're just going to add all those numbers together to get our total distance. So again, we're just going to go into Desmos, do a new line, and then we're just adding up all those numbers. So we're doing 24 plus 42 plus 58 plus 40, and that gives us the total distance with units of kilometers, right? All of these had units of kilometers. So when we add up that total distance and get 164, that's 164 kilometers. And that's how you would get the total distance. It's 164 kilometers. You could do this problem. And so that's basically, I find this the quicker and the easier way to do distance and displacement problems, but it requires that we kind of know conceptually what it means to have a displacement. But thinking about it like this makes our thought process and the work a lot easier, because we don't have to draw 4 vectors, and then that's going to get really messy. If you draw out your coordinates and go 24 to the right, 42 to the left, 58 to the right, and 40 to the left, you should end up at the same, if you work through all of that, you should end up with the same answer. You should end up with the starting point being the same as the ending point. It's just that it's going to be pretty messy, and it's going to be kind of cluttered whenever you have all of these distances and displacements along one axis. So when it's in one dimension, this is a nice way of handling it when you have multiple displacements and multiple distances to talk about. And we'll see that this way of organizing the information is also really helpful, especially when we start getting into when you have displacements and distances not in one dimension, but in 2 dimensions, where things are moving at angles and things like that. But that's in 2 units. So for now, this is what we want to think about in terms of doing distance and displacement problems, where we're finding the total distance and the total displacement over an entire trip that has multiple parts to it, not just moving from one point to another, but moving from one point to another, to another, to another, to another, and then asking the question, what was the total distance and the total displacement? So this is an example for how you can handle those based on what we've seen so far. Hopefully now the homework will be pretty straightforward. That is available for you in UT Quest for you to take a look at. If you have any questions, please reach out. And if not, then yeah, thank you for your time. Again, sorry about the tech issue, but hopefully this clears stuff up. And yeah, hope you guys have a great weekend. Thank you for your time, for your participation, and have a great day.